So now we're looking at the activity series of the elements. So we've looked at identifying some chemical reactions, balancing some chemical reactions, predicting some products. This is actually going to let us predict products of certain chemical equations better, because the activity series is a list of elements that's organized to tell us which is more reactive than another. Typically, like in this case, a greater activity means a greater ease to lose electrons. So we know our metals want to lose electrons. This is going to look at which of our metals are going to lose electrons more easily and thus react more than others. Also notice for nonmetals, greater activity means a greater ease of gaining electrons, which is something we've talked about already. So as an example, most of these reactions we're looking at, they're going to be single replacement reactions. So in this first one, notice there's aluminum solid put into a solution of zinc chloride. Notice it's aqueous, and a lot of these reactions are going to be aqueous. So we have a zinc chloride solution right here. We're putting in our piece of aluminum, and notice we have a reaction. We'd see the presence of reaction because we might see a color change here, maybe some bubbles, but definitely probably a color change, especially on that strip of aluminum metal. And notice we make zinc, and then aluminum chloride goes into the solution. So the aluminum has replaced the zinc. This is a single replacement reaction. This, if we were putting together a reactivity series, aluminum would be more reactive than zinc. Aluminum would be above zinc in our reactivity series. Now, however, looking down at the next one, we have cobalt and we have sodium chloride. Notice in this instance, there's no reaction. That means sodium is more reactive. Sodium is more tightly bound to that chlorine, is not willing to switch places with cobalt. So in this case, sodium, we'd say, is more reactive than our cobalt. We had put it above the cobalt in the reactivity series. So if we go through a whole bunch of metals and we do similar reactions with all of them, we find something like this. Now, notice this is an activity series of not every metal on the periodic table, but more of the common ones. Notice there are some types of trends here. Notice most of our most active metals are either alkali or alkali earth metals. Those are primarily going to be our more active metals. Notice at the end are what we consider our precious metals: silver, platinum, gold. Those are our fairly unreactive metals. So we have alkali earth metals generally at the top, and we have rare earth metal, well, not rare earth metals, let's call them precious metals at the bottom. Okay, so precious metals down here. Now, is this something we have to remember? Oh, I hate to say that we have to remember it, but you know, there are some distinct things that we should know. We should recognize that these things are more reactive than things down here without having to look at a chart. So you should know alkali earth metals are going to be more reactive than something like a precious metal like silver or platinum or gold. Notice there's ways that they're defining these as well. They're saying that these metals are so reactive, they're going to react with water, they're going to react with oxygen, so they're going to react, and we've seen that before. We've put sodium in water, we've put calcium in water, we've seen those reactions with water. We know that they'll react with oxygen in the air. Our next step down, notice, they'll react with steam, with hot water, because there's enough activation energy, and with acids, and they'll react with oxygen-forming oxides. These reactions are not going to be as vigorous. Once we go down to things like cobalt, nickel, lead, again, they will rust, they'll form oxides, they will react with acids, but they're not going to react with water now. So we're stepping down the reactivity series. Once you get to things like copper, copper will rust, it will react with oxygen-forming oxides, but they're not going to react with water, they're going to not react with acids. And then again, once we get down to our precious metals, they're fairly unreactive, they're not going to react with a lot of things. So here's how we're going to use the reactivity series. That reactivity series will allow us to predict whether or not a reaction is going to happen. So I have chromium, I'm reacting it with water. I want to know, is chromium going to react with water? Well, let's go back to our reactivity series and see where it is on this series. Well, chromium is right here. It says it will react with steam, but not with cold water. So if we have liquid water here, this is going to be no reaction, because chromium is not reactive enough to react with cold water. Okay, what about platinum and oxygen? You know what? That one I don't even have to look up, because I know platinum is one of my precious metals. It's down here. It's not going to react with many things, not typically going to form oxides. I'm going to say no reaction. Now we have to look at cadmium and hydrobromic acid. So hydrobromic acid, is cadmium going to react with this acid? Well, Cadmium is fairly further down our reactivity chart, but notice where cadmium is. So it's not our most reactive, but it's still reactive enough that it is going to react with our acids. So a couple things going on here. We have the cadmium react with the hydrobromic acid. So cadmium is right here. Again, it says it's going to react with acids, but another thing we can look at is a lot of reactivity scales are going to have hydrogen on them. If they're above that, they're going to replace and produce hydrogen. So they're going to replace hydrogen if it is bonded to an acid in those types of conditions. So notice some of these don't react with water, but all of the ones above hydrogen on this table will react with hydrogen. So what are we going to form? Well, we're probably going to form, and this one just wants to know if it's going to react or not. So yes, this is going to react. And this one down here is yes, it's going to react. I know magnesium is an alkali earth metal. That's telling me it's probably a fairly reactive metal. I can check my chart just to make sure, but notice where magnesium is. Alkali earth metal, yeah, it's going to react with steam pretty easily. Now here's some more from your book. Let's see, nickel reacting with water. Again, liquid water, this is saying. Well, again, at first we're going to have to spend a lot of time just comparing with our reactivity chart. Nickel is right here. It is above hydrogen, so it'll react with acids, but notice what it says, these do not react with water. So nickel is not going to react with water. This is no reaction. And again, a lot of these, we're going to have to reference our activity series. As we've done this more, as we do this more though, we'll kind of get an idea of our most common metals, where they are on the chart, and we won't have to reference it so much. Notice things like B, we shouldn't have to reference our chart because this is between halogens. So we just have to look at the halogen row, and as the halogens go up, so we have iodine, we have bromine, we have chlorine, and we have fluorine. As we go up this row, the things get more reactive. So the things on top will replace the things below them. So bromine will replace iodine. It will not happen the other way around. So this, yes, is going to occur. Now, notice we have gold reacting with acid. Gold, it should be like an alarm going off. Gold is a precious metal. It is not going to be very reactive, not going to react with many things. Gold reacting with acids is not going to happen. It is going to be no reaction. Let's look at a few more from your book. Now, zinc reacting with water. They're telling you that this is at 50 degrees. Well, 50 degrees is slightly warmer water, 50 degrees Celsius. Not hot, though. So again, let's go back, look at our reactivity chart to see where zinc is. Okay, I found zinc. Zinc is right here. Notice it says these will react with steam, not with cold water. 50 degrees is warm, but it's definitely not steam. So this probably not going to happen. I'm going to say no reaction, maybe mild reaction, but probably no reaction. Notice, again, these metals are small, are alkali metals, and our small alkali, or our more reactive alkali earth metals, I should say, they're going to react with cold water. Things that aren't alkali earth metals, probably not going to react with water. How about tin and oxygen? I'm going to say yes, because most things are going to oxidize. So I'm going to say yes here. The only things that aren't going to react with oxygen, again, are going to be our precious metals, gold, platinum, silver. Otherwise, if we look at our chart, most of our things, even all the way down here, are going to react with oxygen. It's a fairly common reaction. The only ones that do not oxidize, and this is why they're precious metals, because they don't rust. They don't react with oxygen. We're not going to get a rusting with silver and platinum and gold. That's why they're precious metals. That's why they're used in not only jewelry, but really high-end electronics as well. Ooh, now I like ones like this. Now we have to compare a couple metals on the reactivity list. We're dropping some cadmium into a lead nitrate solution. Is cadmium going to replace the lead? Well, here's lead right here. Here's cadmium. Cadmium is higher up the chart. It is more reactive, so it can replace our lead. So if they're more further up the chart, it can replace the lead. Now, what are we going to form? Well, we'll kick out lead as lead solid, and we'll make some cadmium nitrate. I don't really know offhand the oxidation number of cadmium, but I'm going to guess it's probably a +2. If I had to go with some oxidation number, that's what I would guess for most of my transition metals. Last one here, copper with acid. Is this going to be a reaction? Again, most of our metals will react with hydrochloric acid. Notice hydrogen is right here, though. Copper is below it. Copper is one of our less reactive metals, so copper actually is not going to react with our hydrochloric acid. This is going to be no reaction. Most do. Copper, fairly low down the chart, below hydrogen on the chart, so it doesn't react with acids.